if you can see my screen now with the CXHYOZ, the red one, could you please type a 1 to the Skype chat? Okay, yeah, thank you. Everyone can see it? Yeah. Like I said before, so plus oxygen form carbon dioxide plus water. If you want to balance, you can balance the equation, but not necessary. And I'll just quickly write down the molar mass. The molar mass for carbon dioxide is 44 gram per mole. The molar mass for water is 18 gram per mole. Okay. You know their corresponding mass, you can work out the number of moles. Okay. So number of moles equals to mass divided by molar mass. Mass is 44 grams. Mass is 44 grams, and your molar mass is 44 gram per mole. So you get 1 mole. Okay. And for hydrogen, you use 22.5 divided by 18. So number of moles you should get 1.25. Okay. So you get 1 mole of carbon dioxide, which means you get 1 mole of carbon, right? And 1.25 of water, you will get 2.5 moles of hydrogen. Right? Because in each water molecule, you have 2 moles of the hydrogen molecule. Okay? Each moles of a water molecule, you get 2 moles of the hydrogen molecule. So 1 mole of carbon and 2.5 moles of hydrogen. And so you know this x here equals to 1, and this y here equals to 2.5, and we just need to work out what's z over here. You know it has an overall mass of 18.5 grams, right? 18.5 grams equals to mass of carbon plus mass of oxygen plus mass of hydrogen. Mass of carbon, we worked it out already. You have 1 mole of carbon, right? 1 mole of carbon means that's 12 grams. And you have 2.5 moles of oxygen. Each mole of oxygen is 1, so 2.5 moles of oxygen is 2.5 grams. And then you just use simple subtraction. 18.5 minus 12 minus 2.5 equals to 4.5 grams. 4 grams. 4 grams. Okay. So the number of moles of oxygen equals to mass divided by molar mass, which is 4 divided by 16, which is 0.25 moles. Okay. So now we have our empirical formula, which is C1H2.5 O 0.25. Remember, we never leave any decimal place, we all turn them into integers, so multiply everything by 4. It's C4H10O, C4H10O. If you're happy with how I work out the empirical formula, could you please type a 1 to the Skype chat? If anything you don't understand, please quickly ask me. A simple mass balance. Yeah. So this is my empirical formula, and then I need to check the molar mass, right? And this one has already have a molar mass of 74, and you can see given molar mass, where it is. Given molar mass is also 74. Okay. So in this question it's a bit special. The empirical formula and molecular formula is exactly the same. I'll just ask a quick question. What if they given you a molar mass of 148? Okay. Yeah, what's the molecular formula then? Race, could you please tell me if they given you the molecular weight is 148, what's the molecular formula then? yeah, it will just be Ca8H20O2. Okay. In this case, just because of the molar mass they give it to you and the one you find is exactly the same, so just stay over here. And then they just ask you to draw all possible structural isomers. Sometimes, because you want to draw all structural isomers, okay, so you need to make sure you draw it in a consistent way, you don't miss anything. Yeah, so first of all, we need to work out the functional group. Right, first step, make sure you always work out, do it step by step, okay? In all the last few questions, all unknown structure, you need to work out the structure of the compound. So your step 1 is always work out the degree of unsaturation. Right? Always work out the degree of unsaturation. Right? Degree of unsaturation compared with CnH2n. And so in this case, yeah, Dia, could you please tell me what's the degree of unsaturation for this compound? Yeah, 0. Okay. Degree of unsaturation equals to 0. And then step 2, we need to work out the functional group system. Right? So functional group system is so with degree of saturation equals to 0 and 1 oxygen. Okay. Dia, could you please tell me what are the possible functional groups? Yep, alcohol and ether. Okay. They are the only two possible functional groups. Remember, we only have 3 different types. Degree of unsaturation equals 0, 1 oxygen is alcohol and ether. Degree of unsaturation equals to 1 with 1 oxygen is aldehyde or ketone. Degree of unsaturation equals to 1 with 2 oxygen is acid and ester. Make sure you remember that. So we know it's alcohol and ether, we'll just wrote it over here. So it could be alcohol or could be ether. It could be alcohol and could be ether. So with 4 carbons, right? So 4 carbons, 1, 2, 3, 4. That's the first alcohol, and then you can change it to the middle. Right, I think that's it for 4 carbons. And then you reduce it to 3 carbon. Right, you can either put the alcohol groups in the middle, so that's a tertiary alcohol, or you can put your alcohol in the end, that's a primary alcohol. And that's all the structural isomers for alcohol. And whereas ether, you can have 3 carbon, 2 carbon, or isopropyl group. Okay, so you draw the 7 things and you get full marks for the first question. That's full marks for the first question. Anyone has any question? All happy? Okay. And the second step, second question. Second question, they ask you to identify all the stereoisomers. So we've learned stereoisomers could only be geometric isomers or optical isomers. Ash, could you please tell me, is that possible to have a geometric isomer? Do you think with geometric isomer, it's cis and trans, E and Z, double bond? Yeah, yeah. So always do it by elimination. So whenever this is stereo and you need to think about it, okay, it can only be geometric or optical, right? And it is impossible for geometric isomer in this case because we don't have any double bond, we don't have any ring. Okay. So please remember, if you want to have any geometric isomer, you must have a double bond or a ring. If you don't have either, you can never have a geometric isomer. And so in this case, we can only have a stereo isomer. Optical isomer. So optical isomer, you just find any chiral carbon. you just find any chiral carbon. So remember what's a chiral carbon? Chiral carbon is a carbon attached to 4 different groups. Okay? Carbon attached to 4 different groups. So we just need to examine them one by one. Okay? The first structure, we don't have any stereoisomer. Okay? Second structure, we do have a stereocenter, which is over here. The way you label stereocenter is always draw asterisk on the carbon. Okay? That's how they will ask you to draw it in the exam as well. So you can see this is stereocenter because it connects to 4 different groups. Acyl group, methyl group, hydroxy group, also a hydrogen group. Okay, so you attach to 4 different groups, so that's a stereocenter. And this one nothing, this one nothing, this one nothing, this one nothing, this one nothing. Okay, so there's only one optical isomer. When you can just label like that, you get full marks. Okay. So that's the answer for the second question. Now let's have a look at the last question. Last question says, given A react with sodium to form bubbles. Just this information eliminate a lot of possibilities. Okay, eliminate a lot of possibilities. Okay. So Dia, could you please tell me how do we use that sentence? A react with sodium to form bubbles. Yeah, it can't be any esters. Okay, can't be any esters. So it's just alcohol. Okay. So you directly eliminate all the esters. So just those 4 possibilities. Okay. Now let's read the rest of the sentence. I will type to next page and I will read it together. So the first sodium one, just tells you it is alcohol. Okay, so you only have 4 possibilities now. Okay, it also tells you A react with concentrated H2SO4 under high temperature to form B. Okay, form B. So alcohol react with concentrated H2SO4 under high temperature to form B. So with concentrated H2SO4, we only learn 2 different conditions, okay, which is 140 degrees and it's 170 degrees. Okay, at this moment, we can't decide which temperature, but when you read the second sentence, it will tell you the information. Okay. So it says B react with 60% H2SO4. Okay, B react with 60% H2SO4. Race, could you please tell me, based on this condition, is the temperature 140 degrees or 170 degrees? Yeah, it must be 170 degrees, right? Because 140 degrees will form an ether, 170 degrees will form a double bond. Okay, we know ether doesn't react with H2SO4. Only double bond react with H2SO4. So we locate the temperature must be 170 degrees, and B is something has a double bond. B is something has a double bond. Double bond react with 60% H2SO4. That's just an addition reaction. Right? That's just addition reaction. Followed by Markovnikov's rule. Right? Followed by Markovnikov's rule, and you will form some kind of alcohol. You will form some kind of alcohol. Okay? And this is your compound C. Okay. So next question says, say react with acidified potassium permanganate and the solution stay purple. Okay. Say react with potassium permanganate, but the solution stay purple. David, could you please tell me, based on this information, what type of alcohol do we have? Yeah, we'll have a tertiary alcohol. We'll have a tertiary alcohol because both primary and secondary alcohol, when it react with potassium permanganate, the solution will turn into brown and then into colorless. Okay, only the tertiary will stay purple. So we know C is a tertiary alcohol. And C and A, okay, read this hint. C and A have the same molecular formula. So C must be one of those four as well, right? So we just go back to one of those four formula, pick the tertiary alcohol. And so now let's go back. So out of those four, you can see this is a primary, this is a primary, and this one is a secondary, this one is a tertiary. Okay, so C must be this structure. And then you just work backwards to guess what's B and what's A. Okay, so we know C is this one. So we go back and write down C over here. Oh, oops. Alright. Wrong page. Yeah, so we go back to C, and we know C is the alcohol. So this is a structure for C. Something, a double bond under addition forms C, right? So you know the double bond must be over here. Doesn't matter if you choose left or right, okay? They are the same thing. And then OH group react with this to form B. Right? So your OH group must be over here. Right? If your OH group is in the middle, then it's the same as C, right? We know A and C and A and B and C, they're all different. So your OH group must be over here. Okay, your OH group must be over here. Yeah, so this is our A. This is our B. This is our C. Okay. So you can see a simple question test everything you learned this session. So that's the final answer. Okay. This is a kind of question you expect in your exam. If you're happy with this question, could you please type a 2 to the Skype chat? I'll give everyone have a 1 minute to look through it, make sure you completely understand it. Okay. What is the degree of unsaturation? Degree of unsaturation tells you whether you have any double bond. So 1 degree of unsaturation is either a double bond or ring. 2 degree of unsaturation could be a triple bond or 2 double bond.